All right, here are some solutions that will help you get ready for our upcoming test. Question number 1 and 2 both involve writing linear equations, equations of lines, that are either parallel or perpendicular. So parallel will have the same slope, perpendicular will have negative reciprocal slopes, and let's see how those come to play in questions 1 and 2. Question number 1, we're looking for something that is parallel to this line right here, and that passes through the point 5, 2. Well, parallels tell me it's going to be the same slope, so my first objective is to get the y by itself so I can read the slope. So subtracting 5x from both sides, we'll get the y alone. And once the y is alone, then I'll be able to tell what the slope is. So the slope is -5. And that's the slope that I'm going to need. Looking at the choices, it can't be those two choices because they have slopes that are 1/5. Those would be perpendicular. So it's down to choice 2 or 4. Now to break that tie, you could use the graphing calculator and see if it goes through the point 5, 3. I'm just going to use y equals mx plus b to break the tie, because I know that the slope is going to be -5, and from the information in the question, I know that the x in the question is 5 and the y in the question is 3. So I can put those numbers to use to figure out what b is worth. So -5 times 5 is -25. If I add 25 to both sides, I'll get 28, positive 28, as my y-intercept. Okay, going on to question number 2. A student wrote the following equations. Are they parallel, the same line, perpendicular, or just plain intersecting? So wouldn't be able to really tell unless I solve each of these for y, get y by themselves. So I can start this one by subtracting 6 from both sides. And that gets me close to getting y by itself. And then divide everything by 3. So that first equation becomes that. And now I know the slope for that first equation is 2/3. So now I'll have to do the same thing to find the slope here, getting y by itself. So the very first thing I would do is add 3x to both sides, which makes it a positive 3x now on the right hand side, and then divide everything by 2. Turns that second equation into this form right here, and I can see that the slope there is 3/2. So 2/3, if I compare those two numbers, 2/3 and 3/2, those are reciprocals of each other, but they are not negative reciprocals of each other. So the answer would be that they're intersecting but not perpendicular. To be perpendicular, one would have to be negative and positive, and it'd have to be flipped. It's different equations, so they're not the same equation, and the slopes are not the same, so it's not parallel. Okay, moving on to question 3. All right, in question number 3, we're doing a dilation of an equation of a line, and that will either keep the equation the same or it will just change the y-intercept only. So right off the bat, I know that I'm going to get a line that's got the same exact slope, so it has to be choice 1 or 2, and it's going to change its y-intercept. A picture of it might actually help break the tie of which one it could possibly be. So if I start off by graphing the equation, you could do that on a sheet of graph paper. The original equation is like that in white, where the y-intercept is 3. And if I'm dilating from the point 0, 1, I'm dilating from this blue point here, not the origin. If I was dilating from the origin, the 3 would just get multiplied by the 2, and the y-intercept would become 6. Instead, I'm going to think about this one as we did with the compass. If the center of the dilation is 2 spaces away from the center of the dilation, and I was dilating it by 2, I would place my compass right on the center, spin the compass once, spin the compass twice, and the brand new center, or the brand new line would actually, the image would actually go through the point 0, 5. So you could think about this as if you were swinging a giant compass, putting the pointy end of the compass on the center of the dilation and swinging out once would give you a dilation of 1. Swinging out twice would give you a dilation of 2. And that would reinforce the idea that we're doing the question correctly. So not an easy question to do because of the center of the dilation being not at the origin, but a quicker way to get the answer is just to realize that the center is not on the original line, so that the y-intercept would actually change. That'd be a faster way actually to get to the answer, since it's multiple choice. Hey, in questions 4 and 5, we're dealing with equations of a circle, and in question number 4, we're given an equation that is very easy and convenient to use. Because of the way it's handed to us, we can tell automatically, because of the way that it's written, that the x-coordinate for our center will be -1, and our y-coordinate will be a +5. So it's down to choice 2 and choice 4. The number at the end represents the radius squared. If the radius squared is 16, then the radius would be 4, making it choice 4. In question 5, we're not handed the equation in this pretty form right here, so we're going to have to turn this equation into one that looks like this. And the technique that I use to do that is called completing the square. What I call it is split and square. And the very first step that I do is to get all the x's next to each other and all the y's next to each other. I get the x's next to each other by just moving them around like you're moving furniture around. The y squareds I can put right next to the y squared I can put right next to the 2y, and I'm leaving a little space next to both the 10x and the 2y. And I'm noticing that there's a 17 here on the left-hand side. Since it doesn't have an x or a y, I'm going to subtract it from both sides just to kick it to the other side. And now I can use that split and square technique. What I'm going to do is I'm going to create the answer down below here at the same time as I work on creating perfect squares in the line above. So you're going to see me working in both areas, here in this line and also in the answer simultaneously. exactly the same time. So I'm going to split and square. So if I take that negative 10 and split it, I get negative 5. So in my equation, it's going to be x minus 5 squared. So I split the negative 5, or the negative 10 into negative 5, and now I'm going to square it to create a positive 25. If I add 25 on the left-hand side, I'm going to have to add it on the right-hand side. Now I'm going to do the same thing again with my y's. So I'm preparing my answer. I'm going to start by splitting 2. If I split 2, I get 1. And now 1 squared gives me positive 1. Whatever I do to the left-hand side, I have to do to the right-hand side as well. And if I add those together, negative 17, 25, and 1, I will get 9. And now I can identify the center of the circle as being positive 5, comma, negative 1, and the radius would be the square root of 9, which would be 3. Taking a look at question 6, it says, I know how to use slope to judge if segments are parallel or perpendicular. So this was actually a mistake that was made actually on the June 2010 exam. They claimed that this shape was a rectangle. It looks like a rectangle, and they did not try to make this mistake on purpose. Explain why they made their mistake when they printed this off. Well, to judge if it's a rectangle or not, I'm going to have to take a look at the slopes of all 4 sides and find negative reciprocals. All right, the slope of, let's go with AB first of all. The slope there is going up and over. Looks like it's up 1, 2, 3, 4, 5 spaces and over 1, 2, 3, 4. So the slope of AB is up 5 over 4. Now DC is the same pattern, so it also has a slope that's up 5 over 4. So I'm just going to record that right on the picture. Now for this to be a rectangle, the other 2 sides have to have a slope that's negative 4/5, and it's not. Okay, so the slopes of the other 2 sides are down 2 over 2 for both. Down 2 over 2, which is exactly the same as saying negative 1 over negative 1. So we could say since the slopes are not negative reciprocals, the shape is not a rectangle because it doesn't have any right angles. Okay, I got one last question, I believe, or two more questions to, oh, 3 more questions to go. All right, so I know how to use Pythagorean theorem to determine the lengths of segments. All right, well, there is a way to figure out the slope that you should know. Subtract the y's, subtract the x's, and divide. So when I subtract the y's, I get 52, take away 2. When I subtract the x's, I get 146, take away negative 4. So I'd get 50 over 150. And I can use those numbers to calculate the distance. Now you could do this with the Pythagorean theorem or just use this hypotenuse formula to figure out the lengths. typing that into the calculator, you'll get 158.1. Which is the answer. All right, and then looking at some challenges from the past. It says that there are similar triangles. Okay. Which statement is not always true? Well, without even drawing a picture, I can take a look at the similarity statement, and I'll know that since these are similar triangles, that's what the symbol means, similar, that angle A is the same as angle L, guaranteed. So right off the bat, I'm thinking it's probably that one there. A should be the same as L. Well, let's see what the rest looks like. It should be that B is the same as M. That's true. We're looking for the one that's not true. All right. The perimeters. Comparing the perimeters. The perimeter of this one triangle, if we stack it against the perimeter of the other, it should be an exact proportion as these two here. And the areas are in proportion but squared, so that's actually correct as well. That might take a little extra time to explain why those are actually correct. And I've got the time to do it, so let me show you why 3 and 4 are actually true. I'm just going to draw an example of two similar triangles. We'll call this one ABC. We'll call this other one LMN. If I made them right triangles, it'd be very easy to calculate their areas. I can make up some numbers here. Let's go with this one being 3, 4, and 5, and this one here being 6, 8, and 10. Well, that makes them similar to each other. Now let's actually see if 3 and 4 are actually true. Well, let's start with number 3. The area of this triangle is 1/2 base times height. So 1/2 of 3 times 4, which would be 6. The area of this triangle is 1/2 6 times 8. So 1/2 of 48, which is 24. And I could put those numbers right above there in choice 3 to show you that we'd have 6 over 24. And AC is 3. 3 squared is 9. LN is 6. 6 squared is 36. So 6 over 24 is equal to 9 over 36. Both of them are equal to 1/4. So that one is true. We're looking for the ones that are not true. And then comparing the perimeters, the perimeter of the smaller triangle is 3 plus 4 plus 5. So 7 plus 5, which would be 12. The perimeter of the big triangle is 6 plus 8 plus 10, which would be 16 plus 8, which would be 24. So the scale factor there is 12 over 24. If AB is put into the equation, AB is 4 and LM is 8. You can see that we get 1/2 either way. 12 over 24 is equal to 4 over 8. And that's a thorough explanation of why this is the only one that is true. All right, the last question is a proof. So they're starting me off by telling me that angle ACB, or ACB, which is this one here, ACB, they're saying that that is equal to or congruent to AED. That one there, AED. All right, so I've got two angles that match up. And they're asking me to prove that triangle ABC, that's the big triangle in yellow, is similar to triangle ADE? Well, two triangles are similar if there are two pairs of equal angles. And I can already see that this is taking shape. So thinking back to how we did our proofs from a couple units ago, we're going to be doing our statements and reasons, and then realizing that this is one that actually goes by really fast. I mean, there's really not much to this proof, and actually in just 3 lines it's all over. So line number 1 would be the given fact that ACB is congruent to triangle angle AED. And that's one pair of angles that are equal. Now I just need one other pair, and I can figure that out by using the reflexive property. The reflexive property is when you say that something is congruent to itself, and that's what I need here with angle A. So angle A in the yellow triangle is equal to angle A in the blue triangle. And that's it. That's all it's needed. So now I can say that the triangles are similar to each other. Triangle ABC is similar to triangle ADE by angle similarity. And that's it. If they ask me to do something else, which could be possible on the exam, they might ask me to prove that BC over DE is equal to AB over AD. If they were asking me to do something like that, which they're not in this question, you would finish it up with a version of CPCTC, but the version that goes along with similar triangles, CSSTP, which would be corresponding sides of similar triangles are in proportion, which basically means if you are given two triangles that are similar, or if you have two triangles that are similar, that you can build proportions out of their sides. Strangely enough, I might as well add this on. I mean, they could ask you to prove that AB times DE is equal to BC times AD, and you could do all that work there and just say by cross multiplying. Now that's pretty advanced, but is extra icing on the cake, which is semi-possible, at least for number 4 for the exam. But for this particular question, the question ends, surprisingly probably for you, just after just 3 steps. Okay, good luck studying, and hopefully the video was good for you.